packet pushers.
Hey everybody, and welcome to another episode of Packet Protector, the intersection of networking and security. I'm JJ here with Drew, and today we're talking about BGP security. BGP, of course, being routing, and just like everything else on the internet, it wasn't designed with security in mind, but we've had recently the White House that came out with a directive basically for a call to action for all of not just providers and telcos and content delivery networks, but any organization that's using autonomous systems that are announcing and routing on the internet. We're being asked to implement different security technologies around BGP related to or using RPKI to do route validation and authentication. And so we're having Russ White come on, and Russ has a fantastic 20 plus year history in network architectures and security. He's at Akamai and distributed or DDoS detection group. And again, a long history with BGP. He's participated in many of the different standards and frameworks with internet routing throughout all of the years. He has authored many books and is a very well-known instructor in this course. So we're talking about the different risks associated with BGP in security. So when these routes are not secured and the advertisements are not secured or authenticated, things like route hijacking, TLS hijacking or man-in-middle attacks, route leaks, even cryptocurrency theft that's referenced in the White House document. This is a great session where we're just walking through what everybody needs to know about this technology and then where to start, because this is one of those things where it's kind of a community effort. And even though the benefits don't seem directly related to what we're doing, Drew, when we were talking about this, that this is the community effort of securing the internet better.
Yeah, this is one of those things where this is something that we all need to do together. It's like we've got to keep the internet commons green and open for everyone. And RPKI is one of the ways to do that.
Yeah. So we're going to jump in with Russ and hopefully answer your questions. And remember that you can always join us online and read the show notes, and make sure you subscribe so you are notified of new episodes here. All right, Russ, well, welcome to Packet Protector. And we're talking about BGP security, of course. But before we get into that, can you give us a quick refresher on BGP, just the 10,000 foot view?
That's like 8 hours. No. I don't know if I can do BGP in 5 minutes. Basically, BGP is the routing protocol that provides connectivity for the internet. By the way, when people ask me what BGP does or what I actually do for a living, I tell them I put road signs on the internet, because that's basically what BGP does. It puts road signs on the internet. So all the little packets have their little drivers inside of them, and they know which way to go, which exit to take off.
There's going to be a BGP caricature cartoon of little packets. I can see Drew thinking right now.
I'm just picturing Russ anthropomorphizing every packet on the internet. Precious little babies driving around.
Happy little packets.
Happy little packets. So yeah, that's pretty much what BGP does. It's a rather complex protocol because it's a routing protocol in the sense that it advertises reachability and it discovers topology, but the best path for it is primarily based around, or loop freeness is primarily based around policy, not around shortness. So all the things that guarantee loop freeness in BGP are technically what we call tiebreakers. They're not actually metrics per se. They're tiebreakers. They break the tie between multiple routes that have the same policy. So everything is very policy. So that's kind of my 2-second overview of what BGP does for a living.
So for our purposes, one of the things we want to communicate is that BGP relies on autonomous systems, which are essentially sort of self-contained domains, and then autonomous systems communicate prefixes with each other, and that's how your traffic gets from A to B, essentially, across these autonomous systems. And so that's one of the problems that we're going to be talking about, because essentially these prefix advertisements or route advertisements are kind of just based on trust.
Yeah, so an autonomous system is basically a single network under a single administrator, is effectively what you can think of an autonomous system as. That doesn't always hold true. You can have multiple autonomous systems under the same administrator, but typically in that case, you're going to have a big company like Microsoft or Google or somebody like that, and they're going to have multiple autonomous systems for different business units. So it's still under one administrator. And so the other thing that was originally a thing of BGP was that an autonomous system should look like one blob. The policy should look the same no matter where you enter or exit the autonomous system. That's not really necessarily true any longer, but it's still a good construct to understand what an autonomous system is. It's a blob under a single administration domain that also looks totally opaque from the outside world because the policies are externally consistent.
So, from a visualization standpoint, for anybody that's a network or a security architect, kind of envisioning the Visio diagram and entry and exit points, are we looking at AS numbers in the terms of anything that the company or organization is doing that's public and internet facing, or is it within their own WAN environment for advertising their space? Like, where is it used in non ISP context?
Well, a lot of data center fabrics use BGP to provide routing in the data center fabric. We use BGP a lot with something called EVPNs to produce layer 3 VPNs and layer 2 VPNs. So 20 years ago, when I first started this nonsense and doing networking, I would go to large enterprise operators that are enterprise operators, or however you want to put that, and say, really, your company is big enough now that you should really split your network into multiple domains and use BGP to talk between the domains. And I had this conversation with banks and gas companies, and they would all say, oh, no, we don't know BGP. We only know EIGRP, ISIS, and OSPF, and that's it. We don't know anything about, not even ISIS. ISIS has like always been the one nobody knows. And so now it's funny because I go to large companies and even places within the company I work for, and I say, really, we should apply ISIS to this problem and run BGP on top of it. And they all say, oh, no, we don't know IGPs. We only know BGP. It's rather like, what did we do? How did we forget? Everything's weird about this.
I did once have to take an expert level network exam on internet routing, which is not what I did. And I don't even know how I passed it, but I remember ISIS and I remember martini. And all I'm thinking is, oh, we're going to have drinks during this. I'm so excited.
Draft martini. Yeah. Could be something like that. Yeah.
So this September 2024, the White House National Cyber Director released a roadmap calling for more secure BGP routing, specifically recommending things like route origin validation, ROV, and route origin authorization, ROA, which is enabled by the use of RPKI. And before we get into the details of how these things work, what are the problems that RPKI and ROV and ROA are meant to address?
So effectively, there are two basic kinds of problems at the very edge of the network. When a provider talks to a transit or a tier 1 or tier 2 or whatever, talks to a downstream, there's a couple of things you got to watch for. One is that your downstream is not advertising routes they don't own. Now, typically we call this a hijack, but it isn't always intentional. It's often unintentional. And so you'll have situations where somebody will say, well, wait a minute, I have all these routes internally and I'm just going to redistribute them into BGP. And like, boom, all of a sudden they're advertising routes that are private space or other things. And another instance is, well, I really don't want YouTube traffic to come in on this interface. I want it to come in on that interface. So they do some tricks with their upstream to advertise things a certain way. And that leaks and all of YouTube ends up going through their network. And so these are the kinds of things that you're trying to get around.
Now, Russ, you use that example, but the whole YouTube thing actually happened,
Happened.
but inversely and somewhere outside the US, I can't remember the country, but
Yeah.
they were trying to block or stop or reroute YouTube and somehow advertised all of like what happened there?
So sometimes what you do is if you don't want someone to be able to reach you, to get to your network, to send packets to you, what you will do is you will advertise the routes that you don't want to get to you with your upstream or the next hop beyond provider's AS number in the AS path. Because if a router sees its own autonomous system number in the AS path, it discards the route. So this is a very easy poisoning technique. So there's not a lot of information about what happened in that particular case, but apparently it was part of the Great Firewall of China, and they were determined to block YouTube coming in a certain way. So they played some tricks with BGP routing to try to stop it. And unfortunately, they played the tricks wrong. They'd used the wrong policy, and they ended up advertising reachability to YouTube. And to make matters worse, they did it in a way that meant the entire world preferred their route.
Oof.
And so,
Surprise.
yeah, we don't know if that was intentional, unintentional. Like, there's not a lot of data around what actually happened there. But on the routing table side, on the default free zone side, which is what the global routing table is called, you could see like there were these routes coming out of China and you could see their AS path and you could kind of guess what they were trying to do. And you could kind of see how they fat fingered their policy, that it caused a problem. So this is kind of external. We're guessing at what actually happened failure.
And I think this is a perfect example of why the White House is issuing guidance, because I like your example of you said, oh, I hang street signs on the internet for a living. But if you don't work in the space of internet connectivity and routing, If you just imagine humans in cars driving down the highway and you see signs of where you think you want to go and you go off that way and it takes you down some weird shady neighborhood and then you get jumped, right?
Yeah.
Like this is the problem we have with the route advertisements as they're happening right now, right?
Yeah, or classic examples. You drive by and you see one of those little blue signs and it says there is a restaurant of type X at this exit.
Mhm.
And you jump off, and then it says X is 5 miles down the road, or it says make a right here, make a left there. And by the time you get to the restaurant you were trying to get to, it's 5 miles off, and you have no idea how to get back to the highway, right?
Right.
This is the problem with these kinds of signs. And on the opposite side, there was a guy who lived in LA. This is a very funny story. And there's a particular left exit on some highway, and it wasn't labeled. And so everybody who lived there knew how to get where they were going, knew to make that exit.
Mhm.
But there was no sign. So he went out and painted a sign to add the correct exit information and hung it next to, off the bridge, next to the official signs. And it was there for like 15 years before anybody noticed.
And it's fine if somebody's being helpful, but if somebody's being malicious, this is a problem, right? We want to authenticate somebody advertising routes and make sure they have the authority to be advertising that route to us on the internet.
Correct. That's all it is.
Yeah, I think that's the issue we're going at, in that there's obviously misconfigurations which can lead to things like you essentially DDoSing yourself. But there are also times when folks, for whatever reasons, might advertise routes they don't own because they want traffic sent to them for nefarious purposes.
The other one you see a lot, believe it or not, is spam or DDoS attacks. And I'm going to originate a DDoS attack from an IP address space, but that IP address space is owned by somebody else. So what I'm going to do is I'm going to peer with an upstream. I'm going to advertise that space for 5 minutes, launch my attack, and then disconnect and let the table go back to what it was. And in the meantime, I'm now untraceable because the origins of my packets are pointing at someone else who actually owns that data. That's a pretty nefarious use. Another pretty nefarious use is I want to play man in the middle with TLS sessions.
Mhm.
And so I advertise your route in a way that they direct traffic to me. And then I go ahead and forward it along, but after it passes through my man in the middle,
Mhm.
right? So there are some nefarious use cases here, as funny as some of them are, but there are some that are truly bad use cases.
Yeah, which is why we wanted you on Packet Protector to talk about, because we're interested in the bad use cases.
Now that I'm thinking about this, we can go down this rabbit hole a different day, but a lot of the security tools we're using in other areas, right? Let's talk about email security that uses trust mapping. And one of the things it takes into consideration is what was the data path of this thing coming here? And that changes whether or not we trust that piece of mail coming in.
Yeah, you do an Azure ARPA reverse lookup to see if the source, and then you might actually ping or helo that source and try to open a session. Well, if I can control the origin of the route, then I can spoof your email address. I know exactly how email security works. I can actually spoof all of that and make you accept the email. And then I disappear, and it looks like the person who sent the email is an innocent bystander completely, but I actually sent it.
Oh, there's a whole long list. Okay, so let's dive into, we're talking about route origin validation and authentication, but this is all part of a framework that's related to basically having a PKI infrastructure within this context.
Correct. So this is all predicated on there being a set of root keys for a PKI system, a resource public key infrastructure system. So it's private public key pairs. This is all asymmetric encryption is what we're using here. Usually you use asymmetric encryption to exchange private keys, and then you encrypt using private keys. And that's because of performance, right? That's strictly because you simply cannot unencrypt traffic using a public key system, an asymmetric key system, fast enough, right? It's just a performance hog. And so all chipsets are designed, if they do encryption and unencryption, it's all about private. But anyway, this is all asymmetric. So what happens is you take some root of trust. Now, the anchors that are usually given are the regional route registries, or RIRs.
Right.
Regional Internet Registries. So say you go to APNIC. Now, it used to be that you owned IP address. You don't anymore. You lease it. All the older stuff that's grandfathered in is owned. By and large, now you lease it. So say you want to lease a /24/12 or whatever you're going to lease. When they do that, they're going to validate procedurally. And see, you said before that BGP is really about trust. Well, it's funny because, yes, it is. Because what happens is you don't peer with people unless you have a contract with them. And so all of the work that goes into peering is not configuring BGP. Configuring BGP is the easy part,
It's
right?
writing the contracts.
It's writing the contracts,
Oh, boy.
right? Who pays how much for this? What are you going to send me? You
Mhm.
know, when is this going to be reviewed? How do we measure this? What rate of S flow I'm going to use to determine the traffic flow levels? All that kind of stuff is all contractual. So in reality, RPKI is also contractual. There are technical elements to it, but what you're doing is you're going to this RIR and you're saying, Mr. RIR, I would like a /12 / pick a number. And they say, okay, who are you really? And they're going to go back and check you out as a business or as an individual.
Mhm.
And once they do that, if you have an AS number or if you request an AS number to go with that route, they're going to issue a public key or an ROA, a route origin authentication or authorization. And then they are going to say, this AS number belongs to this route,
Mhm.
to this reachable destination. And now, if you are a BGP speaker, you can say, okay, I know that AS 65,000 goes with 192.168.100.0/24, right?
Mhm.
And if I get that route from another origin AS, I'm safe to discard it because obviously it's not coming from the right AS number. That's effectively how it works.
Okay, so there's essentially a certificate system for validating this AN is associated with these prefixes or routes, and I can trust that I can accept them or bring them into my policy environment.
That's correct. And there are other pieces to it. Like you can say the longest prefix I will ever advertise is a /20 in this space. So if somebody advertises a /24, which would technically win in the global routing table, it doesn't really win, by the way, it's a different route. But anyway, and you know that because they're advertising a /24 and the resource holder has told you the longest they'll ever advertise is a /20, this is not a good route. Doesn't matter what the origin AS is. It's not a good route. Throw it away. Those are the kinds of things that you get out of RPKI.
Okay. And just because anytime there's a certificate and a PKI infrastructure, we talk about the certificate authority and that whole infrastructure, which I'm assuming is being built. And it sounds like that's tied to the registries here in the US. And I guess in North America, it's ARIN. So they are running these certificate authority systems themselves. Are we paying for that? Are we having them do that? Are they delegating some of that?
So by and large, they run their own certificate authority
Okay.
infrastructure. And there is a protocol that is used to carry it around. It was originally done with rsync, which is really kind of not a very good way of doing things at a global internet scale, but that's kind of what was being done. Now there is actually a separate protocol for synchronizing. So it's basically a database of certificates, and everybody synchronizes with somebody who synchronizes to the RIRs, to the registries. And then you get this big conglomerated database that should contain every available prefix, all 1.x million of them, 1.2 million, whatever it is, with a certificate saying this AS number belongs to this prefix. And then there's another protocol called Router RPKI protocol that then a lot of commercial implementations, in fact, FR Routing implements it as well. So there's at least a couple of open source implementations that support it as well, that there is a specific kind of server that runs that protocol that you put that in there. And then when the router receives a route, it queries this database. So the router's not carrying all this data,
Okay. Mhm.
right? It's outside. And so you query this external server and the server comes back and says valid, invalid, something.
So it's kind of proxy cache, something that's floating out there that's acting as a source of truth or repository. Okay.
But I think it's important to underline that you want your routers to do the routing. You don't want them to also be doing this, keeping all of this in their memory or in a table. They can just do a lookup to some known server.
Or even doing the crypto.
Right.
You don't want routers doing the crypto, right?
Even understanding that they're taking on only a piece of this capability, does this mean, I would assume this is potentially, we need to upgrade certain pieces of equipment. What depth? Is this a hardware upgrade, software upgrade? Where's that line?
So potentially, by and large, most routers that can handle a full internet routing table, the 1.2 million routes in V4 and I don't know how many routes it is in V6 right now, should be able to handle the workload of querying. Now, the other piece that's going to come into play, however, is going to be speed of convergence.
Mhm.
And most implementations allow you to either check before you do best path or after. And there are advantages and disadvantages to both of those, right?
You mean check to see if this is a valid route?
You can actually check. And some implementations will allow you to peer with another router consume their entire routing table. When you get to end of RIB, which means my routing table exchange is done, then you run your best path, and then you, in the background, lazy double check everything so that you're not impacting initial convergence speed. And then on one by one basis, they'll go ahead and check before they run best path.
I see.
So it depends. There's very simple implementations.
Yeah, it would depend on how many false negatives and false positives you get as to which you might want to process first then.
And how much churn you want to introduce into the system, right? The problem with internet routing is not the scale, it's the churn.
You mean the number of updates that happen?
Yeah, the internet never converges.
Right.
Never. At any moment in time, if you could ping every address on the internet, you would probably find, if you somehow had some magical way to ping every internet address, every address attached to the internet at any given time, somewhere between 5 and 20% of the addresses are unreachable. But it's for like 2 seconds or 5 seconds or something, and you don't really notice it because like there's a convergence process. But BGP is always converging. It's all in the internet. It's forever converging. So the amount of work involved is, I guess, one of the problems that we do face with BGP security in trying to secure BGP.
Do you feel like this ROV and ROA approach addresses the issue of route leaks and route hijacks sufficiently to be worth whatever effort it takes to implement this and then also just keep it operating?
Yeah, I think so. I think ROV, ROA is a good place to be, at least as a baseline. I think in the long run, we'll need more stuff, but I don't know that there's a good answer to what the more stuff needs to be at this point.
But this is a good start, at least.
Yeah, oh yeah, this is a good start. And you combine this with, there is now a peer type in BGP. So you can actually say I'm downstream or I'm upstream. And then if you enforce first AS, then you actually prevent a large proportion. You have to remember, what's the diameter of the internet? People find this really crazy.
What's the diameter of the internet?
What's the diameter of the internet? How many ASs do you pass through going from any source to any destination?
Oh,
Huh.
I don't know.
Yeah, this feels like a trick question.
It's not a trick question. It's well researched, and it's hilarious because it's been the same for about 20 years.
Really?
Yeah, it's about 4 to 4.2 ASs.
I was going to say 5 is just a random number I was pulling out of my butt.
Yeah, no, it's between 4 and 5, and it's been between 4 and 5 for 20 years. Like, it's crazy, but it's always been that number. Jeff Houston's done whole presentations on how weird it is that the internet doubles in size and the diameter of the internet doesn't change.
That is crazy.
Is that because of sort of the original allocation of IP addresses or just a concentration in service providers that's how it worked out?
It's just that we peer much more richly.
Okay.
We just have that much more peering than we did back then.
Okay.
Russ, I have a question around the document coming out of the White House, which is what attracted Drew and I to this topic and having you on was this document. We thought like this is more than just a 20-second title to cover because it applies to any organization, not just ISPs.
Yeah.
And content delivery networks, but any organization that has an ASN. And some of the numbers that I saw in this document, if they're right, were kind of a little bit weird. So it was kind of saying that the percentage of the prefixes protected by this in the US is less than 40%, whereas in Europe, it's more like 70. And I'm kind of wondering, why is there such a discrepancy there?
Okay. This actually starts with politics.
Europe always kicks our butt on different security policies, don't they? Right, they do.
It's more like, so ARIN in the early days had, and I don't remember exactly what the policy was, but there was this very strange policy about who assumes risk in certain situations. And Europe went a completely different direction. And because of the way Europe set theirs up, a lot of the providers in Europe were like, yeah, we'll do this, not a problem. And you'll also find a very high percentage in Latin America. But remember that when this first came out, the Latin American providers, they were just physically smaller. They just didn't have the connectivity. So it was almost less of a brownfield. In the United States, we have such dense connectivity. First of all, it's a lot harder to deploy this. I mean, you look at where I work, Akamai. Okay, I don't know how many POPs we have. I have no idea how many BGP speakers we have. I know that it is in the tens of thousands. And so you start implementing something across tens of thousands of BGP speakers, it's far different than implementing it across 5 or 20 or 100, right? And so it's just a scale problem to some degree here in the US or in North America. But it's also, there's politics involved. Like I said, there's just greenfield versus closer to greenfield versus closer to brownfield. There was also a lot more previously owned space that is not leased in the United States
Okay.
versus Europe and Latin America and stuff. Most of the old prefixes that were just given away by ARIN at the beginning of the internet were given away in the United States.
Uh-huh.
There were a couple in Japan. There were a couple in United States, Canada, but there were a couple in Japan. There were a couple in Europe. The Wide Project has one, some other things like that. But by and large, it's just a lot harder to make the US work. And the politics of how ARIN was trying to do their who takes responsibility for things just made it a lot worse. Like a lot of providers just balked at it and said no. Another thing to remember about this is that this is a risk. Suppose that I lease an address space from APNIC.
Uh-huh.
And then the Australian government comes down and tells APNIC to shut my network off for some law in Australia, but that law doesn't apply in the United States, for instance. Well, now, if you are a content provider and your job is like your Rackspace or your, I don't know, Google Cloud or AWS Cloud or something, and you provide cloud services or whatever it is, and the Australian government comes down and says, shut their route off, you're now out of business while you're litigating, right? And so this was seen as a huge business risk. So another thing that's happened more recently that's helped boost this a lot is that people now can do double ROAs.
What does that mean?
They can get an ROA from APNIC and they can get another ROA from ARIN. And now if one of the two cuts them off for whatever reason, it could be, I forgot to pay the bill. It may not be political at all. It might be my accounting department lost that bill and I forgot to pay it, kind of a thing. It could be anything. Now you can actually say, if you're big enough and your business really relies on it, you can say, no. That's okay because I have another ROA.
Got it. Which means your routes will still be valid and accepted as valid by other BGP speakers.
Exactly. So this was a huge risk early in the days of ROA that I think has been kind of worked out at this point in various ways. And beyond which, honestly, the RIRs, when this first came out, a lot of people were very concerned that the RIRs would be quick to fold in the case of pressure.
Fold to what?
Fold and take somebody's route.
Oh, okay. Uh-huh.
Right. And that is not proven to be true. Most of the RIRs have proven to be much more resilient than the original scare about this.
You mean to government pressure coming in and saying, hey, RIR, pull this route. They've fought back. Okay.
Exactly. Yes.
Okay.
I mean, it's the same thing with a DNS provider, right?
Mhm.
You go register your DNS name with Network Solutions, pick somebody, it doesn't matter, whoever it is. And the government comes in and says, pull that DNS name. Well, right or wrong, you're out of business until it's litigated. Right? And if it takes 6 months to litigate and you're in a fast growing market, you're out of business.
Yeah.
That's just the way it is. And so my favorite story of this, the thing that alerted me to this is my stepfather used to work for a provider and an edge provider, a last mile provider. And their main competitor came in and bought the company that was doing their accounts receivables. Now imagine how much havoc you can do against a company if you own their accounts receivables.
Mm-hmm.
You can just run things by the contract as much as you want to, but you can really mess with somebody's revenue stream by doing that and basically put the company he worked for out of business.
Wow.
And sure, there were court cases, but
right.
Yes. Well, and so much stuff now is, cloud connected, interconnected, SaaS hosted, entire companies are running their own internal infrastructure in the cloud.
Right.
That whether you're working internally or servicing clients that way, even if you were just a regular company, this can be extremely disruptive. And I think it's a timely conversation with this White House document, but it's also challenging because, it does sound like the governments are having to intervene in some ways. It's like being a good corporate citizen of the information highway here. It's not in their mission statement to just take out the trash and keep stuff clean. I don't want to say there's no direct benefit, but this is what we're asking organizations to do. And, I have a question around, does a networking team deal with this? Does security deal with this? Like, whose responsibility is this? Because it's not something directly tied to a business objective for most of these organizations, but they're being told we have to do it.
Right. I'll start by saying that if you want to understand routing security in the global internet, the simplest way to visualize it is a problem of the tragedy of the commons. You have your little village and everybody owns sheep. And as long as everybody controls their sheep, the greens stay in good shape and everybody can feed their sheep, right?
Mm-hmm.
But the moment somebody buys twice as many sheep and they overfeed on the commons, then everybody's sheep die.
Mm-hmm.
And this is the global routing table. This is what it is. It does not hurt me to advertise a longer prefix. It does not hurt me if somebody behind me hijacks the prefix for 5 minutes to attack someone. Like, these aren't things that hurt me as a provider. They hurt the internet. But I have no motivation financially other than, oh, if everybody doesn't play right and well, the commons fails. And that has been the classic problem with the global internet routing table ever since it started, basically. I mean, going all the way back 30 years.
So are there business arguments then for implementing ROV and ROA? Because I assume it is going to have some cost, at least in time and effort.
Yeah, and it also has a cost and complexity,
Mhm.
and it does kind of open you to new kinds of attacks. There is an attack surface here. You're increasing your attack surface to some degree or another. Now, not as bad with ROV and ROA with next steps. And that's part of the problem with anything anybody recommends for next steps. Beyond ROV, ROA, you're caught on the horns of a dilemma about opening up huge new attack surfaces for incremental security gains. And you don't really know. I don't think that the incremental security gains are better. I don't think you gain much. I think the trade-offs are too harsh.
You're talking about BGP security mechanisms beyond ROV and ROA that could be implemented if everybody did this.
If everybody did this, yeah. So I think there are problems. There are some I don't mind, like ASPA, I think is good. If you look up ASPA, I think that one's not bad, but we could probably do a whole nother show on all of that stuff if you ever wanted.
I think we need to.
So I think that from a business perspective, the biggest two things you have are, I want to be able to work with government entities. And this is going to be required for, what is it, Fed on-ramp? And so on-ramp, Fed, US government, and every other government in the world is going to eventually require this. They're just going to. There's no way around it. So that's going to be one thing. But if you don't do business with the government, why do you care? Well, people that are providers are starting to catch on and say, I won't peer with you. I won't accept your business unless you do the right thing from a security. And this has been going on for years, just not with ROV and ROA. So I assume that this will eventually be added.
You could see this getting added to those contracts that organizations set up when they peer. Are you compliant with ROV and ROA?
That's correct. Yeah.
What's a good starting point? So if somebody's listening to this and they're in an organization, because this White House document talks a lot about critical infrastructure, which is almost everything we all do in our daily lives, right? And I know a lot of our listeners work in, everything from government to schools to retail to transportation. If they're saying, okay, I would like to understand this more and maybe not just implement it, but of course, go pitch it internally and make this a priority for my organization. Are there, besides the White House sort of mandate here, are there technical references and resources and places people can go look or things they can Google for that would help through this process of knowledge?
Vendor documentation, perhaps. There's also RIPE, I think, and NANOG both have courses on this. If I were going to do this as a company, and we actually need to get back to your who's responsible for this, because I think that's a hard question too.
Oh, see, I thought you were just avoiding that question.
No, I'm not avoiding that question. No, it's fine.
Nobody wants to answer that one.
I'll answer it, actually. So my perspective on that is, if you have a real cybersec team that knows keys and knows key rotation and knows how to protect the data, I would give the key server to them because network dudes don't know anything about protecting host. I mean, in theory, we should, right? But your average network engineer is not going to know how to protect your ROA host against DDoS attacks or against lateral movement within your network or whatever it is. That's just not what they do. And they don't necessarily know how to harden the host correctly. And that database, for whatever reason, needs to be stored, not necessarily in a place where it's private, because it's really public information.
Right, it's supposed to be public, yeah.
But in a place where it can't be taken down.
Yeah, because like you said, you're doing something new here that is a different attack vector or vulnerability.
Right. And then I would let the network team own the router piece of it, right? I set up the connectivity to this host. I make sure that my upstream is done correctly. I make sure that I'm double checking my routes that they're being signed. I'm actually going out to Looking Glass server and making sure that my routes are set up correctly, doing the analysis. That's all on the network team. But that host that contains the encrypted information and runs the encryption, I would hand that to the cybersec team myself. That's where I would put it. So what else were we talking about?
The courses.
Resources.
Places to get information. Yeah, resources. I actually have not looked at RIPE or NANOG, but that's where I would start to see if they have courses.
I found a link from ARIN that has a FAQ on RPKI, so we'll include that in the show notes.
Okay, cool. I don't know if there's specific training or configuration help beyond what you might find in vendor documentation, and that's going to be on the router side. What I will say is there is a large community called Manners,
MANRS.
MANRS, and it is in ISOC, Internet Society. There's a Slack, there's a mailing list, and everybody in that community is more than willing to help you figure this out if you need help with it. Now, if I were going to implement this myself, I would start by saying, do I own my own AS? If I don't own my own AS, then my only real implementation option is to go my upstream and say, can you please sign my routes for me unless you're already doing it? Can you please create ROAs for me? I shouldn't say sign my routes because I want you to sign my origins for me. So that would be the place I would start if I didn't own an AS. If I did own an AS, I would still be likely to go to my upstream and ask them for help because they're going to know where their ROA servers get the information from. And they're going to be able to give you IP addresses to point at. And they're going to be able to give you advice. And because you're their customer, they're likely to help you. Beyond that, I would go to the Manners community myself. That's where I would go.
We'll link to that in the show notes.
Yeah.
Nice.
Well, I feel like we just scratched the surface. So, Russ, we're definitely going to have you back to talk about BGP security some more. But in the meantime, where are you online? Do you have anything you want to promote? Where can folks get stuff from you? You mentioned, I know you do the Hedge podcast and you've got a great blog. So,
yep. The Hedge podcast, rule11.tech. I'm also doing Rule 11 Academy now, which is my own training thing. So I would actually start with rule11.tech because I point to everything from there. That's the first place to start.
Rule11.tech will have that in the show notes. I'll also just tout that you did a Learning BGP series for the Packet Pushers. That's on YouTube under your name. Go check that out too if we've piqued your interest in BGP. That does wrap up this episode. Thank you, Russ, for being here. And thanks to you for listening. If you have a topic you want us to cover, you can find us on LinkedIn, or you can find us at packetpushers.net/community, where you can join our free Slack channel with other IT and security pros. If you've got a comment, a correction, or a question, reach out at packetpushers.net/FU. The FU is for follow-up. And we appreciate when listeners reach out. As always, eat those security vegetables.